JC students, do you struggle with P and C questions, especially those that ask you to form combinations from a word, right? So let's take a look at this. We have a quadratic word over here, and quadratic is made of these alphabets, right? Q, U, A, D, R, A, T, I, C. And the restriction of this question is that we must form all of them in a circle, whereby the A must be separated from the T. Now, when you say A is separated from the T, a lot of people might immediately think, oh, slotting method might work, right? But slotting method will fail in this context because if let's say I have a circle over here, and then I say, okay, I want to slot my A's here, or here, right? We miss out a very fundamental case, which is the question didn't say that the two A's cannot be together, right? So we will definitely miss out cases whereby A can be side by side together over here. So how do we actually compute this and still let the A's be together or A's be separated while at the same time making sure that they are all separated from the T? The way we do this is actually this way, and it's actually a very interesting way to do this. What we can do is we can group the T together with two different letters first, right? And since it cannot be grouped together with the A's, we got 1, 2, 3, 4, 5, 6 letters to choose from that we can put in a group together with T. So let's start off by taking 6, choose 2 first, right? And then within the group itself, we got 2 ways of arranging the letters around the T, right? Ensuring that the T must be in the middle. So this is something that we have to enforce. So 2 letters in the group, we arrange them, so 2 factorial around the T. And then that means that at the end of it, we left with 1, 2, 3, 4, 5, 6 and 7 distinct groups. Now arranging 7 distinct groups in a circle, we have 7 minus 1 factorial, right? We need to minus 1 because in the circle there's this problem called the rotational symmetry. However, notice that I have 2 identical A's. So if I put one A here and one A here and versus let's say another A here and another A here, right? Even though this may be A1, A2 and A2, A1, they are exactly the same because we only see A, and A, right? So to account for these symmetrical identical objects, we need to divide by 2 factorial to remove the identical combinations. And therefore, our answer to this will be 10800 ways, which is the final answer to this question over here. So to all JC1s, to all JC2 students, I scored A for A-level H2 Math last year as a private candidate when I went to take the exam completely all by myself. And the reason why I did this is to prove that whatever we teach at the Math Tuition Center actually works today, especially at the national level standard. And if you are still struggling with H2 Math and your exam is only in about 7 months, make sure to WhatsApp the number on the screen over here and I will find a slot for you to come in and let's work together to ensure that you can go from any grade you are right now to scoring A for H2 Math by the time your A level comes at the end of the year. For more information on my classes, WhatsApp the number on the screen here and I look forward to seeing you in person.